All right. In this video, we're gonna focus on Anova. That is one-way Anova. The full meaning of Anova is said to be analysis of variance. Analysis of variance. Analysis of variance. Okay. So let's take a note on Anova here. Let's take a note on Anova. Okay. Please write. Anova is based on F-test. Anova is based on F-test. So we are calculating for Anova. We are calculating for F-test. Either call it F-test or you call it variance ratio or variance ratio. Okay, so our intention here in calculating for Anova is to find this F-test. Okay, or you can also call it variance ratio. It's the ratio of the variances. Okay, please take note. Okay, now let's take the types of F-test. We have two types of F-test. Please write. F-test can be divided into two. F-test can be divided into two. F-test. Okay. F-test can be divided into two. F-test can be okay. I'm sorry for this. I'm sorry. Okay, please write. F-test can be divided into two. Can be divided into two. And let's know the two F-tests. The first one here said to be F tab, or you call it F critical. Okay, the second one here, let's get the second one here. The second one here is said to be F dark or F statistics. Please take note. So let's focus on the first one here, that is F tab. How do we solve on F tab? How do we find a table, and what is responsible in finding the table? Okay, please write subheading F tab. Remember, either I call it F tab or I call it F critical. Either I call it F tab or F critical. Please take notes. So please write. F tab depends on degree of freedom between and within. F tab depends on the degree of freedom within and between. So in terms of calculating F tab, we have two degrees of freedom, that is degree of freedom within and degree of freedom between. Now let's know the formula for degree of freedom within. Now either you call it degree of freedom between or you call it degree of freedom treatment. Okay, please take note of that. Either I call it degree of freedom between or degree of freedom treatment. Now either I call it degree of freedom within or degree of freedom error. Please take note. Degree of freedom between or degree of freedom treatment. Degree of freedom within or degree of freedom error. Please take note. Okay, now let's know the formula for degree of freedom between. Now degree of freedom between here, the first one here, okay, the degree of freedom treatment is said to be equal to class rho minus 1. Please take notes. The degree of freedom, sorry for this, degree of freedom treatment or between is said to be rho minus 1, while the degree of freedom within or error, the degree of freedom within or error is said to be rho times column minus rho. Please take note of that. Degree of freedom within or error is said to be rho times column minus rho. Please take note of that, okay? Now that means this is what we need to calculate for F tab, okay? This is what we need to calculate for F tab, okay? So how do we make use of this degree of freedom within and degree of freedom between? The degree of freedom between is the same as treatment. So yeah, degree of freedom within is the same as what? Error. Please take note of that, okay? Now let's try to know how to, okay? Treatment is for between, while within is for error, okay? Within is for error, treatment is for between. Please take note. So let's try to know how to make use of the table. Now this is how we make use of the table here. The table can either be depends on the percentage. So we have two tables here. We have two tables of variance here. We have the table for, this is the table here. We have the table for when the level of significance is 0.05. So if you are given 0.05, that means you use this table for F. So if you are given 0.01, we use this table for F. Please take note. Okay, now if the level of significance, now in terms of the table here, please take note of this. In terms of the table here, this part here, please listen to me carefully. In terms of the table, this part here is always between, while this part is here is always within. This is always between. Now this area here is always within. So if I have the degree of freedom, when I calculate the degree of freedom and I have this to be 2 under assumption, and I have this to be 3. So to check for maybe, let me just say 5%. Okay, so I will use the one of 0.05. This is 0.05. Now we say that I told you guys that this part here is said to be between, this one is within. Okay, now we have to look for, sorry, let me get, okay, now this is the complete one here. Now this is for, remember this 0.05 again, it's not different, 0.05. so here we assume the value to be for between, we assume the value to be 2. That means this is 2. While for within we assume for within in this this thing F 0.05 level of significance. Okay, I told you guys that in terms of the table here, the natural table, this is always between. This part, this serial number here is always between, while this serial number here is always within. So under assumption from sorry for that, under assumption from this, we say that the treatment or the between is 2, while the error or the within is 3. Okay, so we have to locate this. This is 2, this is 3. Let's get where they intersect. That is 9.55. so that is how we got our 9.55 here. Okay, what you just have to do here to get the calculated F calculated is to hit the subscribe button and you can get everything about statistics. Okay, this is Go Best and this is Best Academy TV, the best TV in the world. Thank you.